Okay. Now, after that portion of organic chemistry, the last unit of this part, second, is hydrogen. It is a very small unit. Already CBSE has removed some part of this for this year examination. So, I am going to teach you only that part which is included by CBSE for 2021. Now, you are familiar with this hydrogen. You know well about hydrogen. Now, first we are going to discuss the position of hydrogen in periodic table. Position of hydrogen in periodic table. Hydrogen in periodic table. Periodic table. What about the position of hydrogen in periodic table? Still, in the modern periodic table, the position of hydrogen is not justified. Why it is not justified? There are certain cases for it. Now, first of all, A part is resemblance with alkali metal. Resemblance with alkali metal. Resemblance with alkali metals. Hydrogen resemble alkali metal in a number of properties. What are those properties? Let us see one by one. Number first, electronic configuration. Electronic configuration. Both of them, both means hydrogen as well as alkali metal, both of them have one electron. Suppose I am writing hydrogen atomic number 1, its electronic configuration is 1s1. Now you see it is having one electron. Similarly, if I write an alkali metal sodium atomic number 11, its electronic configuration will be 1s2, 2s2, 2p6, 3s1. Now you can see both hydrogen as well as alkali metal, they are having one electron in their outermost shell. So hydrogen is resembling alkali metal. Number second, electropositive nature. Electropositive nature. Electropositive nature. This means what? Both have tendency, hydrogen as well as alkali metal, both have tendency to lose one electron and ion. Yani both hydrogen as well as it loses this one, it will also lose one electron, any positive plus electron. Now both alkali metal as well as hydrogen, both have same tendency to lose one electron. The oxidation state, common state of oxidation state of +1. Yani both hydrogen as well as alkali metal, they are exhibiting oxidation of +1. Why? As they lose one electron. As they lose one electron to form positive ion, they lose only one electron to form positive ion. So their common oxidation state is +1. Okay, for example, if I am writing HCl, example you see, now Cl is -1, this will be +1. Similarly, if you write NaCl, this will be -1, this will be +1. Now you see both hydrogen as well as alkali metal, they are exhibiting which oxidation state? +1. Clear? Number 4. Affinity for electronegative element. Electronegative element. Electronegative element. Both have strong affinity. Both have strong affinity for electronegative element. Electronegative element, and both can combine with electronegative element. Okay, let us see example of this. Example, for hydrogen I am writing HCl, H2O, H2S. Now you see, chlorine, oxygen and sulfur, they are electronegative in nature. Clear? Now, what about alkali metals? If you write alkali metal, NaCl, Na2O, Na2S. Now you see, both hydrogen as well as alkali metal, you can see clearly over this. Hydrogen and alkali metal, they are combining with electronegative element. They have strong affinity for these elements. Okay. And last, number 5th, both act as reducing agent. 5th, both act as reducing agent. Both act as reducing agent. Just we have written, they have tendency to lose electron, and loss of electron represent which agent? Reducing agent. They easily lose their electron. So both are behaving as reducing agent. So this is the properties in which what is happening? Hydrogen is resembling alkali metal. Okay, now let us hydrogen resemblance with halogens. Hydrogen resemblance with halogens. Number 1st, electronic configuration. Now you see, electronic configuration to attain nearest inert gas configuration. Inert gas configuration. Now you can see both are needing one electron to acquire nearest inert gas configuration. Suppose I am writing hydrogen. Now you know its electronic configuration is 1s1 plus it is taking this electron, it is converting into H negative. Its electronic configuration is 1s2, and this 1s2 is electronic configuration of helium. It is representing helium. Similarly, if you write fluorine, it requires also one electron. Its electronic configuration is 1s2, 2s2, 2p5. It takes this electron, it converts into F negative, and you see F negative electronic configuration 1s2, 2s2, 2p6, and this is the configuration of neon. So both these elements, hydrogen and fluorine, they are taking one electron. After gaining one electron, they are attaining nearest inert gas configuration. Clear? Number 2nd, ionization enthalpy. Ionization enthalpy. Both have small atomic size small atomic size. So they have greater ionization enthalpy, and both have greater ionization enthalpy. Okay, hydrogen. This is hydrogen in gaseous state. Its ionization enthalpy is near about 1312 kilojoule per mole. Okay, if you are writing chlorine in gas state, Cl, its ionization enthalpy is 1556 kilojoule per mole. Now you see कि both hydrogen as well as what? Halogens, they have greater ionization enthalpy. This is second. Both exist as diol. Example, let us, I am writing hydrogen H2, halogen F2, chlorine Cl2. Now you can see both exist as diatomic molecule. Number 4, electronegative nature. Electronegative nature. Both have tendency to gain one electron, to form an ion, yani both. You can see hydrogen, it is gaining one electron, it is forming an ion, H negative. Similarly, F fluorine, it is gaining one electron, it is forming F negative. The formation of this negative ion indicates electronegative nature. Clear? Number 5, oxidation state. Both exhibit -1 oxidation state. Both are exhibiting -1 oxidation state. For example, if I am writing NaH, you see example. Hydrogen is -1, this is +1. Similarly, if I have written NaCl, Cl is -1, sodium is +1. Now you can see both is having -1 oxidation state. And last, nature of compounds. Both hydrogen as well as halogen, both forms covalent compound. They are forming covalent compounds. Both are forming covalent compounds. Clear? Both are forming covalent compounds. Can you give the example of covalent compound of hydrogen? I am writing H2O. This is a covalent compound. NH3. It is a covalent compound. H2S. Covalent compound. Then similarly, covalent compound of halogens. Can you write covalent compounds of halogens? You replace this hydrogen by halogen, you will get the covalent compound of halogens. Suppose we write ClO, it is a covalent compound, and Cl3, it is a covalent compound. IF5, it is a covalent compound. So both are forming covalent compound. So we have seen a number of properties in which hydrogen is resembling what? alkali metal as well as halogen. Now what about the position of hydrogen in periodic table? Conclusion. From the above, it is concluded that hydrogen position is not fixed. In periodic table. It shows anomalous behavior. In a different behavior. It shows anomalous behavior. So, its position is not justified. In periodic table. Therefore, hydrogen is studied separately. It is neither studied with alkali metal nor it is studied with halogen. The entire chemistry of hydrogen is separate. Clear? Now, moving on, occurrence. Next topic is occurrence. Occurrence of hydrogen. Occurrence of hydrogen means 92% of universe. 92% of universe is made of hydrogen. You see, is made of hydrogen. Clear? Earth crust contains only 0.9% of hydrogen. Earth crust is containing hydrogen in a very minute amount, but the entire universe, it is made up of hydrogen. It is found in combined state. In oceans, coal, petroleum, plants and animals. This is how hydrogen is found in nature. Okay, universe is made up of hydrogen. In combined state, it is found in oceans in the form of water with coal, petroleum, plants as well as animals. Clear? Now, next is isotopes. Isotopes of hydrogen. Now, you are familiar with the isotopes. You have heard about isotope. Isotopes means element having what? Same atomic number but different mass number. So, it has three isotopes. Hydrogen has three isotopes. Okay, first is protium. Second is deuterium, and third is tritium. They are the three isotopes of hydrogen. Protium, it is represented as 1H1. Deuterium, 2H1. Tritium, 3H1. Okay, this you can write this as P, this you can write as a D, and this can be written in the form of T, tritium. Clear? It is containing what? It is containing one proton. This is containing one proton plus one neutron. Here neutron is 0. It is containing what? One proton plus two neutron. And this tritium, T we are writing. Okay, what about the nature of these? This is non-radioactive. Non-radioactive. The first two are non-radioactive, but tritium, this isotope of hydrogen is radioactive. It is radioactive. So these are the three isotopes of hydrogen. And last one is radioactive in nature. Understood? Then physical properties or properties of hydrogen. Properties of hydrogen. Properties of hydrogen. Number first, it is odorless, colorless, tasteless gas, Hydrogen has no smell, no color, no taste. Number second, it is non-polar in nature. Hydrogen, it is non-polar in nature. It is a non-polar. Number third, it is very light. It is very light, or we can say it is the lightest of all elements. It is the lightest of all elements. This is 4. Number fifth property, it is difficult to liquefy. It is in gas state, difficult to liquefy. Means to convert hydrogen into liquid state. It is very difficult because its critical temperature is very low. Critical temperature is very low, and this is near about 22 Kelvin. Now you see, it cannot be liquefied. It is difficult to convert hydrogen into liquid state due to its low critical temperature. Clear? Then ortho and para hydrogen. Now what are these two forms of? You can call them electrodes. Ortho, electropic form. Ortho and para hydrogen. Okay, first of all, ortho hydrogen. Ortho hydrogen. Let us discuss ortho hydrogen. Ortho hydrogen. What is ortho hydrogen? When the nuclei of two hydrogen atom in H2 molecule, hydrogen molecule spins in same direction means clockwise. It is ortho hydrogen. Ortho hydrogen. I am drawing ortho hydrogen over here. It is ortho hydrogen. Now you see ortho hydrogen. This. There are two hydrogen atoms. This is the nucleus of both hydrogen atom. Okay. What is this? This is nucleus. This is nucleus. Now what is happening? If this nuclei is spinning in same direction, if it is spinning in same direction, then it is orthohydrogen. Clear? Then parahydrogen. What about parahydrogen? Parahydrogen. Para, it will be revert of this. Parahydrogen. When the nuclei of two hydrogen atom in hydrogen molecule in H2 molecule spins in opposite direction, spins in opposite direction, that is anti-clockwise, it is parahydrogen. It is called what? Parahydrogen. Parahydrogen. Now let us draw parahydrogen. Parahydrogen means this. Now you see parahydrogen. This is hydrogen atom. Okay. Now they are the nucleus of hydrogen atom. This is nucleus of hydrogen atom. And what is happening? If they are spinning, one is spinning in this form, another is spinning in this form, anti-clockwise, then it is called parahydrogen. Clear? This is what? This is parahydrogen. This one was orthohydrogen. Clear? This is all about hydrogen. Now, let us move on hydrides. Hydrides. Hydrides are basically of three types. First part, ionic hydrides. Ionic hydrides. Now what are ionic hydrides? The name indicates ionic hydrides. Ionic hydrides means when hydrogen atom combines with electropositive element of S block, then it is called ionic hydride. It is called ionic hydride. Okay. S block element yani first group and second group. In these, the elements of S block, the element of S block gives electron to hydrogen atom, Clear? Let us see the reaction of some hydrides. Sodium reacts with hydrogen, forming ionic hydride 2NaH. Okay. Now, if you see its oxidation number, it is -1. This is +1. This is one ionic hydride. Second example, if I am going to write calcium plus hydrogen, calcium hydride. Again, hydrogen. Here hydrogen is -1, calcium is +2. Means these elements, they are giving electron to hydrogen. So these are ionic hydrides. Clear? Now Number first, they are white. Ionic hydrides, they are white, gray, non-volatile, crystalline solid, okay, they all are solid, ionic halides, ionic hydride. Number second, they have high melting point, than metals, means these hydride have higher melting point than sodium, this hydride have higher melting point than calcium. Number third, they are ionic in nature, they form ionic compounds. Number four, they react with water, they can react with water. You write down their reaction with water. Sodium hydride, it is reacting with water to form sodium hydroxide with evolution of hydrogen. Okay, they react with water to evolve hydrogen. Next, this was fourth. Number fifth, these are the characteristics of ionic hydride. Fifth, the stability of hydride, decreases down the group. The stability will decrease down the group, means lithium hydride will be more stable than sodium hydride, potassium hydride, rubidium hydride, and least stable will be cesium hydride. Number 6, they act as reducing agent. All these hydride, they act as reducing agent, means they can donate their hydrogen atom. So this is all about ionic hydride. Clear? Number B. B is metallic hydrides. They are called interstitial hydride. Now what are these hydrides? What are interstitials या metallic hydride? Now you see. The hydrides formed when hydrogen combines with D or F block elements. Are called metallic hydrides. Okay. When hydrogen is combining with an element of D or F block, then the hydrides are metallic hydrides. Clear? Hydrogen is absorbed over the surface. Of these metals, hydrogen is absorbed, it gets deposited over the surface of these metals as they have vacant spaces in them. Vacant spaces or interstitials in them. Now, this absorption of hydrogen, when hydrogen is absorbed on the surface of metal, it is called occultation. The phenomena is called occultation. Absorption of hydrogen on the surface of metal is called occultation. So, occultation is occurring in this case. So, hydrogen, it gets fit in the vacant spaces of these metal. Clear? Hydrogen gets fixed in the pores of these metals. Pores of these metals. Clear? Elements of group 7, 8 and 9 do not form hydride. So it is called hydride gap. It is called hydride gap. Let us see the example of some hydrides. Scandium hydride, okay, chromium hydride, lanthanum hydride, zirconium hydride, copper hydride, etc. So there are a number of examples of metal hydrides. Clear? Now let us continue it. Number first, they are hard and all these metallic hydride, they are hard and lustrous in nature. Number second, they conduct electricity. Number third, their melting point is lower than the metals. And the hydride melting point is lower than, it can be more than one combination. They act as reducing agent. They have greater metallic properties. Okay, the metallic bonding is stronger in metallic hydrides. Clear? Now number C, covalent hydrides. C. P block. Then it forms covalent hydride. Then it forms covalent hydrides. Okay, let us see. Hydrogen is combining with elements of P block. P block means group 13, 14, 15, 16 and 17. For example, we are writing the example. Let us see example. I am writing CH4, NH3, H2O, HC. First, they are soft. All covalent hydrides are soft. Number second, they have low melting point. Okay. Number three, they are covalent in nature. These hydrides are covalent in nature. Clear? Now covalent hydrides. These hydrides are of three types. Covalent hydrides are of three types. Okay, number one, electron deficient hydride. Electron deficient hydrides. It is very electron deficient electron deficient, they act as Lewis acid. Lewis acid means what is going to happen? Their octet is incomplete. If I am writing boron hydride, then it is having only 6 electrons. Aluminium hydride, it is also having 6 electrons. So these hydride, they have 6 electrons in octet. So they are electron deficient. That's why they are called electron deficient hydrides. Clear? Now, number second, electron precise hydride. Electron precise hydrides. The name indicates electron precise, electron number is same. The hydrides having complete octet. Are electron precise, means the number of electrons are balanced. Such are called electron precise hydride. Let us see the example of this. You can quote example CH4, SiH4, GeH4, etc. Here they have precise electron. Their octet is complete. They are having 8 electrons in their octet. How many electrons? 8 electrons in octet. So their octet is complete. So they are called electron precise. Clear? And last is electron number third. The hydride with excess electron is there. They are electron deficient, electron precise, electron excess. What are these? The hydrides having excess electron in their octet. It is more than 8 in their octet. They act as Lewis base, means they are having electron excess. You can call them electron rich. Okay, let us write appropriate word electron excess, or we can write here electron rich hydrides. They are rich in electron. Electron rich hydride means they have more electron, more than 8 electron in their octet. Let us see the example of this. Example NH3. Now you see, this is lone pair electron rich. Water H2O. You can see there is excess electron in this. Yes or no? Similarly, H2S, PH3. There are number of hydrides, etc. So they are electron rich hydride. They are having more than 8 electron. You count over here 5 or 3. It is having more than 8 electron. This and this. So they are electron rich hydrides. They have excess electron, more than 8 electron. We can write more than 8 electron. More than 8 electron. Okay, that's why they are having this lone pair of electron. So they are called what? Electron rich hydride. Understood? This is all about hydrides. So today we have discussed half part of this hydrogen unit. Clear? Please go through it. Try to read it carefully. Note in your copies. The remaining part we will continue tomorrow. That's all for today. Thank you very much.